History is usually taught as a staircase. We assume humanity starts at the bottom with stone tools, steps up to bronze, climbs to iron, and eventually reaches the silicon microchip at the very top. We believe progress is linear, a straight line from ignorance to enlightenment, with no shortcuts. But sometimes, archaeology finds something that breaks the line. In 1900, sponge divers off the coast of the Greek island Antikythera were seeking shelter from a storm. Instead of safety, amidst the beautiful marble and bronze, they hauled up a shapeless lump of corroded green rock. It looked like nothing, just debris fused together by centuries of salt and time. For decades, it sat in a museum storage box, unnoticed and unloved, while the statues took center stage. It was just item 15087. But when we finally looked inside with X-rays, the rock looked back. Inside the corrosion were gears. Precision, interlocking, bronze gears with triangular teeth. This is the Antikythera Mechanism, and according to our understanding of history, it simply should not exist. Dating back to roughly 100 BC, this device displays a level of engineering that vanishes from the historical record for the next 1,500 years. Finding this in a Roman shipwreck is like opening the tomb of King Tutankhamun and finding a jet engine buried next to the sarcophagus. These are called OOP out-of-place artifacts, objects that challenge the narrative of steady human progression and suggest we are missing chapters of our own story. It forces us to ask an uncomfortable question. Is civilization a steady climb, or is it a cycle of rising and forgetting? To understand the magnitude of this anomaly, we have to understand what this machine actually did. It wasn't a toy. It was a simulator. Imagine holding the entire solar system in your hands, capable of fast-forwarding time with the turn of a crank. This device proves that the ancient Greeks had a digital understanding of the universe, long before the first digit was ever processed by a computer. But instead of silicon, their code was written in bronze. And instead of electricity, it ran on human torque. So, let's open the box. Let's look at the source code of the ancient world and see exactly how smart they really were. At the heart of the machine lies a piece of technology that wasn't invented again until the 19th century, the differential gear. In a modern car, a differential allows wheels to spin at different speeds. In the mechanism, it was used to perform mathematical subtraction. By taking the position of the sun and the position of the moon, the gears physically subtracted one from the other to calculate the precise phase of the moon. This is an analog computer. It accepts input, the date, and processes it through a logic gate made of teeth and metal to provide an output. But it gets more complex. The moon does not orbit the Earth in a perfect circle. It moves in an ellipse, speeding up when it's closer to us. This is Kepler's second law of planetary motion, discovered in 1609. The Greeks built this law into a gear in 100 BC. They used a pin-and-slot mechanism, where one gear drives another slightly off-center, physically simulating a variable velocity orbit. This wasn't just observing the sky, this was mathematically modeling it. They had captured the chaos of the cosmos and trapped it in a box of order. It tracked the Metonic cycle, a period of 19 years used to reconcile the lunar calendar with the solar year. It tracked the Saros cycle, an 18-year period used to predict eclipses. It even had a dial to tell you which Panhellenic games were happening that year. Imagine the user interface. A single knob on the side. You turn it, and time flows forward or backward. As you turn, 7 hands on the front face move, representing the sun, the moon, and the 5 known planets. On the back, 2 massive spiral dials rotate, predicting the deep cycles of the cosmos decades into the future. The precision required to cut these triangular teeth by hand, without magnification, is mind-boggling. If one gear was off by a millimeter, the calculation for an eclipse 20 years later would be wrong. It had to be perfect, and because it exists, we know it wasn't a prototype. You don't build a device this complex on your first try. There must have been ancestors to this machine. Wooden prototypes, simpler bronze calculators, a whole lineage of devices lost to rot. This implies an industrial ecosystem. You need mathematicians to design it, metallurgists to cast it, and artisans to cut it. They had the software. They had the hardware. So, why didn't they take the next step? Let's play a game of what if. Let's look at another invention from the same era, the Eolipile, or Hero's engine. Invented by Hero of Alexandria in the 1st century AD, it was a simple steam turbine, a ball that spun when water was boiled beneath it. The Romans treated it as a toy, a temple novelty to amaze the masses. They never connected the dots. But imagine if they had connected the Antikythera Mechanism to the Eolipile. The mechanism provides control and calculation. The engine provides power. This is the recipe for the Industrial Revolution. With these gears, the Romans could have solved the longitude problem 1,500 years early. Navigating the ocean requires knowing exactly what time it is. If you have a perfect mechanical clock, you can calculate your position anywhere on Earth. In our timeline, ships hugged the coast because the open ocean was a death sentence of disorientation. But with Antikythera-class navigation, Roman galleys could have crossed the Atlantic with confidence. Imagine Roman legions landing in the Americas in 100 AD. Imagine steam-powered triremes trading with the Maya. They could have automated agriculture, textiles, and mining. The Dark Ages would never have happened. By the year 1000 AD, humanity could have been on the moon. We lost a millennium of progress. This alternate timeline is so close, you can almost touch it. The pieces were all there, sitting on the workbench of history. So why didn't it happen? Why did the gears stop turning? Why do we have to wait for James Watt? The answer is not technological. It's economic, and it is much darker. The Romans didn't need steam engines because they had something cheaper: slaves. Economy drives innovation. If human labor is virtually free, there is no financial incentive to invest in expensive, experimental machinery. Why build a complex harvesting machine when you can just force 1,000 captives to cut the wheat? This is the slavery trap. An abundance of cheap labor acts as a brake on technological acceleration. The brilliance of the Antikythera mechanism was an intellectual curiosity, not an economic necessity. Furthermore, there was a material limit. They had the software, but the hardware was flawed. Bronze is soft. Gears made of bronze wear down quickly under high stress and rotation. To build a steam revolution, you need high-quality steel to contain the pressure and withstand the torque. The Romans could make steel, but not consistently and not in the quantities needed for mass industrialization. They hit the metallurgy wall. Their math was 1,500 years ahead of their blast furnaces. It's a tragedy of mismatched progress, like trying to run an artificial intelligence on a pocket calculator. The concept works, but the physical reality collapses under the weight of the ambition. So the mechanism remained a luxury item, a toy for the rich, rather than a tool for the world. And because it was rare, it was vulnerable. When the civilization that built it fell, the machine fell with it. We often think that once humanity learns something, that knowledge is permanent. This is a comforting lie. Knowledge is incredibly fragile. It relies on a continuous chain of transmission from teacher to student. If that chain breaks for even one generation, the knowledge evaporates into myth. When the Roman Empire collapsed, the economic network that supported artisans and mathematicians dissolved. Bronze is valuable. During the Dark Ages, if you found a useless rusty machine, you didn't study it. You melted it down to make a spear. The source code of the ancient world wasn't deleted. It was recycled into weapons of war. Libraries burned. Scrolls rotted. The manuals on how to build a cosmic simulator turned to dust. This is the civilizational reset. We fell back down the stairs we had spent centuries climbing. For 1,000 years, no one knew how to calculate the things the mechanism did effortlessly. We suffered from the Dunning-Kruger effect of history. We looked back at the ancients and thought they were primitive. We assumed because they didn't have electricity, they were stupid. But biologically, they were exactly the same as us. They were just as clever, just as curious, and just as capable of genius. They just had different materials. The Antikythera mechanism is a tombstone for a dead future, a memorial to what could have been. It reminds us that progress is not guaranteed. It can be stopped, paused, or even reversed. But there is a hopeful angle to this cosmic horror story, a reason to look up. The fact that they built it means the drive to understand the universe is innate. It is written in our DNA. Whether it is gears of bronze or chips of silicon, we are obsessed with modeling reality. The mechanism was an attempt to capture the chaos of the sky and trap it in a box of order. We are doing the same thing today. Our supercomputers simulating climate change or black holes are just the grandchildren of the Antikythera device. We are not the first time humanity has reached for the stars. We are simply the second attempt. Perhaps this is the definition of humanity, the creature that builds machines to understand where it lives. The mechanism sat at the bottom of the ocean for 2,000 years, waiting in the dark. It waited until we were smart enough to understand it again, until we had reinvented the very technology it contained. It is a message from our ancestors. We were here. We knew. Don't forget again. Civilizations rise and fall. But the math? The math remains. So the next time you look at your phone, remember the bronze gears rusting in the dark. Remember how easily the light can go out, and how hard we have to work to keep it burning. The Antikythera Mechanism was a seed that didn't sprout, but we are the forest that finally grew. Let's make sure this time, the forest survives. Thank you for watching.